All right, fitting right in with our ratio stuff, we're going to look at similar shapes. And basically what a similar shape is you've got two shapes that the angles are exactly the same in both shapes. But one shape is bigger than the other one, or they're different sizes. So the angles are the same, but the sizes are different. And what we're going to do is we're going to look at those kind of shapes and figure out some missing sides uh, using the ratio stuff that we've talked about. And with a similar shape, they're always going to have that same ratio, whatever it is. And we'll show you that. But it really does not, or it will not end up being any different than anything we've done before, but it's just going to be put into a different context. Now, a different word that you'll see come up every now and again is congruent shape. That means that everything's exactly the same. So that means that all the angles are the same, all the sides are the same. That would be congruent. We're not worried about that today. We're just worried about similar. But if you ever see this, that just means that everything's the same. Similar just means the angles are the same, but the sides are going to be different, but they should have the same ratio. So let's take a look at a few here. Here's a couple of shapes. We got two trapezoids right here. I know it's a trapezoid because I've got one pair of parallel sides. These shapes are similar, but we need to figure out what this bottom is going to be here. So I've put in the angles over here, and since I've told you that it's similar, okay, I told you that the shape is similar, that means all these angles should be the same. So I'm just going to go through and put them in the spots where they belong here. Now, this trapezoid is turned, so you may have to draw it turned the same direction as this to understand what I'm talking about here. But this 120 degree angle is right here. Oops, let me make that a little bit smaller. This 120 degree angle is right here. This 60 degree angle would match up with right here, and this 60 degree angle would match up with right here. Now let's work on the ratio stuff. What I'm going to do, and you know, if you've been comfortable with doing this a different way or figuring it out a different way, that's fine. I'm going to start it out like this because I think it's a good visual here. So I'm going to put small trapezoid, big trapezoid. And I know that I have sides on both of these that are in the same spot. I've got this 6 right here, and I've got this 10 right here. Okay, so that's how we're going to start our ratio, since they're similar shapes, 6 and 10. My ultimate goal is for the small shape, for this side to be 15, and to figure out what the same spot on the other trapezoid is. So that would be blank right there. There's a lot of ways we can do this. I would suggest in this case to reduce these down as far as we can go here, because we can't do 6 times anything to get 15 unless you use a decimal. So maybe I'll divide these by, how about 2? If I divide them by 2, I'm going to get 3 and 5. Now I should be able to work this out and do just fine here. 3 times 5 is going to be 15, and then I have to times the other side by 5, and my answer for this one would be 25. So my question mark right here is going to be 25. And again, I told you ahead of time that these would be similar shapes. If I tell you that it's a similar shape, that implies that all the angles are the same, and it also implies that the ratio of the sides is the same. Okay, every ratio for every side here is going to be 3 to 5. Okay, so that's something to think about. We'll get into some things that are problems where they'll show that they're not similar because the ratios are not the same. All right, for this one we've got two isosceles triangles. I know they're isosceles because they've got two sides the same and one different. Okay. We've talked about before already that I'm telling you right now these shapes are similar. So I'm just going to fill in these angles where they belong here. This 40, you have to understand that this triangle is kind of upside down, so I'd have to point that upward. So the 40 is going to go there. And then the 70 and the 70 are going to go down here. Those are our angles. And a triangle, all the angles add up to 180 degrees. Now I need to figure out what this missing shape is right here. Or not shape, missing side. I'm telling you that they're similar, so we should have a ratio that we could solve here to figure out what that side is. So I'm going to go ahead and make my chart here, and I will put small triangle, big triangle, and I need to find something that matches up here so I can figure out what my ratio is, and I have something right here, 42 to 20. Okay, so the big triangle in that spot is 42, the small is 20. I want to figure out if the big triangle has 10.5, what am I going to have over here? Okay, so I might start by reducing this down a little bit here. I can divide both of these by 2, so we'll go 10, and then we'll go 21. Okay, that's not going to help us very much, so why don't I find a unit rate? Why don't I divide it so one of these is 1, which makes it pretty easy. If I do 10, I'll divide by 10. 10 divided by 10 is 1. 21 divided by 10 is 2.1. Okay? Now I should be able to do it. What I need to do is I need to figure out what do I need to multiply 2.1 by to get 10.5. In order to do that, I could just divide and figure out what I would have to multiply by. So if I do 10.5 divided by 2.1, I'm going to get 5. Okay? So it looks like this right here was times 5 to get that. So that means from here to here also has to be times 5. So 1 times 5, my answer is going to be 5. So in this question mark spot right here, my answer is going to be 5. And again, all I had to do was set up this ratio, and we've talked about many ways to do this. So there's tons of ways that you could solve this problem as long as you keep the same ratio. And again, I told you ahead of time, these are similar shapes, so that means all the angles are going to be the same. The sides are different, but the ratio for the sides are all the same. Okay, let's take a look at this one here. Let's fill in the angles here. This is basically the top right here if I were to twist this up here. So my 60 goes here, and then my 30 would be down here because my right angle's right here. I need to figure out what it is right here. So I'll set up my ratio table. Small triangle, big triangle. And I need to find two sides that both have numbers so I can figure out what my ratio is. Well, the bottom of both, that would be the bottom, and if I turn that right side up, that would be the bottom. They both have numbers. Small triangle is 8, small triangle is 2, big triangle is 8 for these right triangles. So what I need to do is I need to figure out what is, blank is over here, so what is the big side going to be here if its match on the other one is 8. Okay. And again, this one should be pretty simple here. And again, remember, you can always just count up on this chart would be fine. Let me give myself a little bit more room here. If you can't figure out what to do, if you can get these numbers smaller than the numbers you're looking for, you can always count up. So if I put 8 there and question mark there, I could go 2 to 8, 4 to 16. That would be another 2 here and another 8 here. 16, that'd be 24. And then my next one would be 8 because that'd be 2 more. And then 8 more here would be 32. So my answer for this one would be 32. Now, again, many ways you could do this. Simply, you could do 2 times what equals 8, which obviously is 4, and then multiply the other number by the same thing by 4, which is 32. I could have started with the 2 and the 8 and reduced it down, divide by 2 to get a unit rate, so that'd be 1 and 4. And then if I needed to make this 8, that's easy, that's just times by 8, which would be 32 either way. Now, here's an interesting one here. I'm going to give you a section that has these, but the question is, are these triangles similar? Okay, so the first thing you always want to look at if they're asking, if they're not telling you they're similar, they're asking you if they're similar. You want to look and make sure the angles are all the same. That's a good starting point. So I'm looking here, yep, all the angles are the same. So now I'm going to look at the sides. And obviously the sides are going to be different because they're not congruent. Congruent means they'd be all the same. We're trying to figure out if they're similar, which means we're trying to figure out if they have the same ratio. Okay, so what's nice is I usually pick out a couple of them. So let's see here. Well, I'll just take the small and the big, and let's see. We'll just take the smaller ones here. Let's go 3, and then that matches up with this 10. Okay, and my question is, from this ratio, is there any way to get 15 to 40? If we can't, then they don't have the same ratio and they're not similar. If we can, then they do have the same ratio and they are similar. So can we get from here to here? Well, this is times 5, but this is actually times 4. So since we had to multiply different numbers to get these two sides here, the ratio is not the same. Okay? Or in other words, I can't count by 3 and 10 and end up here. So since the ratio is not the same, these are not going to be similar triangles. So always look first at the angles, because that'd be the easiest thing to look at. If the angles aren't the same in the right places, then it's definitely not similar. But other than that, you'll have to go and see if your ratios for the sides are similar or are equal. And if they are equal, then you're in business. If not, then they aren't going to be. Now, let's say that this triangle had, let's see, how can we change this so it is similar? Let's say we got rid of this 15 here. Let's say we made this, let's see here, how about 12? If that was 12, they would be similar because that would be 3 times 4 is 12, 10 times 4 is 40, or if we count it up, 6, 20, 9, 30, and then the next one would be 12, 40. So if we change this side to 12, they would be similar, but since it was 15, they weren't. All right, what I'm going to ask you to do here is I'm going to ask you to take a look at this one first. And I'm going to put the sides in there for you. Let's see, let's go, I don't know, let's go 6 and, how about 6 and 15? And then let's go, and I will say that these are all right angles, so you don't have to check the angles. 6 and 15, and then let's go 21 and blank. I want to know what that blank is if I'm telling you ahead of time that these triangles are similar, or these rectangles, excuse me, are similar. Over here, I want you to tell me if it is similar by checking on those ratios. Now, one thing I'll show you real quick that I did on purpose just to show you is that right away, I know that these aren't similar to start with because my angles are different. I got 20, 20, and 140. Here I've got 15, 15, and 150. They're not the same. Okay, so I'm going to quick change them so the angles are the same, and then you'll have to figure out by the sides if we've got similar triangles. So there's 140, 20, and 20. So our angles are now the same. You tell me if these triangles are similar by seeing if the ratios are equal. Go ahead and pause this video, give both these problems a try, and see how you do.